Hello students, we are going to have a crash course on class 11 physics and the topic is motion in a straight line. We have the first question. If the distance covered by a particle is zero, then what we can say about its displacement? It is given that distance covered is zero. Distance is equal to zero. Which also means that the body has not yet started moving. The object is at rest. Distance covered by a particle is zero only when the object is at rest. It has not yet started moving, I can say. That is why the displacement must also be zero. Here we have option A as the correct one. Why? If distance covered is zero, the displacement should also be equal to zero, right? Its initial and final positions are one and the same, which means the object has not displaced at all. Where are the other options? It cannot be zero. No, it is already zero. We have written it, right? It is negative. The displacement in this case is not negative. It may or may not be zero. That is also not the correct option. Clearly, the option A, if the distance covered itself is zero, which means that the object is at rest, then the displacement of an object is also zero. Go to the next question. If the displacement of a particle is zero, then what can we say about its distance covered? Given that the displacement of the particle is zero, displacement is equal to zero. What are the different cases under which the displacement can be zero? It can be when the distance traveled by the body is zero. It is when the object is at rest. If an object is at rest, that means the distance traveled is zero. The displacement is also zero. The object has not moved at all, right? It is at rest. Next, the other case can be when its initial position, object's initial position and final positions are different. I mean, initial and final positions are the same. Final positions of the object are the same. What are the examples we can take here? Let us say the object is over here at the point A. It is moving to point B. It has moved to point B in this direction, and from the point B it again comes to point A. It will return back in a same straight line. It is going to come back. So you can see that its initial position and final position, and from that position it is going to come back, right? So we can see that the object has returned back to its initial position after its journey, which means that the distance traveled here is not equal to zero. But what about displacement? That is equal to zero. Why? The object has reached its initial position once again, right? Next, the other example is when the object moves in a circular path. The object is moving in a circle, it takes one full circle and comes to its initial position once again. Then in such case, again, distance is not zero. It cannot be zero. What about displacement? It is equal to zero, right? So we'll look into the options given. What are, if the distance covered by the particle, I repeat, if the displacement of the particle is zero, then what we can say about its distance covered? So displacement is zero. What about distance covered. So if you look into the options here, it must be 0. If you look into the second case here, distance traveled is not always 0, even though the displacement is 0. That is why this cannot be the right option. It cannot be 0. If displacement is 0, there is a chance that distance covered is 0. That is why this cannot be the correct option. It is negative. Here in this case, distance covered is not negative. It cannot be negative. That is why C is the wrong option. If you go to the option D, it may or may not be 0. Distance covered can be 0 or distance covered cannot be 0 if the displacement is 0. That is why option D here is the correct answer. Go to the question 3. Location of the particle has changed. What we can say about the displacement and the distance covered by the particle? Location has changed means object's initial position and final positions are different, right? The object has got displaced, I can say. The object has changed its position. It has already started moving and it has reached its destination over here. This was the initial position. Location of the particle has changed. What about its displacement and distance covered? If you look into this diagram, so this is the initial and final position. The shortest distance between initial and final position gives us the displacement. Distance covered can be calculated or it is measured as the path moved by an object. That means what about the distance here? Distance traveled is not equal to 0. Displacement is also not equal to 0. Hence, the first option, both cannot be 0, will be the right answer here. One of the two may be 0. The second option is wrong. Option C says both must be 0. No, it is also wrong. One is positive, other is negative, and vice versa, which is also the wrong option. Hence, for the third question, the correct option is both cannot be 0. Fourth question. A particle moves with uniform velocity. Which of the following statements about the motion of the particle is true? It is given that the particle is under uniform velocity. If an object is moving with uniform velocity, velocity remains the same at every interval of time, which says that in such case it is under constant speed and constant direction. Then it is also understood that here any change in the velocity can give us the acceleration. If velocity itself is uniform, then what about the acceleration? Acceleration should be equal to 0 since acceleration is the rate of change of velocity. If the velocity of the body change, then only there can be acceleration. Since its velocity is uniform, rate of change of velocity is 0, which means acceleration is 0. There is no change in speed. Speed is constant. The direction has also remained constant. Then, considering this, which of the following statements about motion of the particle is true? The first option says its speed is 0. No, the speed is not 0 here. It remained constant. Acceleration is 0. Yes, here we have already written that acceleration is the rate of change of velocity. It can be written as final velocity minus initial velocity divided by t. Here its velocity is uniform, which means that there is no change in velocity, acceleration is 0. Hence, option B is the correct option. It is given that acceleration is opposite to velocity. No, acceleration and velocity are not opposite to each other. Your acceleration has also become equal to 0. Its speed may be variable. That is also the wrong option. Hence, the correct option here is its acceleration is 0. Go to the question 5. A car travels a distance s on a straight road. A car is moving on a straight road, let us say from A to B. The car is moving, and how much of distance it covers on a straight road is s, and it took 2 hours. How much of time did it take? Let us say t1, 2 hours of time it took. Then it returns to the starting point from A to B and from B to A. It is going to return, and hence it is going to take the time, say 3 hours. It took 3 hours to reach from B to A. What about the distance traveled in such case? It is also the same. The distance traveled will not change, only it has taken different time to reach its destination, right? Then what is its average velocity? Average velocity can be calculated as total distance traveled, by total time taken. Total time taken. What about the total distance traveled here? From A to B it had traveled s meter. From B to A it has again traveled s meter. So I can write s plus s. What about the time taken to travel from A to B? It took 2 hours. To travel from B to A it took 3 hours, right? So it is 2s plus 5. Correct option from the among given options. So the right option is B, 2s 5.